Aloha, Richard Halverson here, and today I'm going to do the cover graphs, and we're gonna look at the breadth first search, and we're gonna do the challenge activity at the end. So let me share my screen. And this is the section we're looking at, 21.6, breadth first search, and it's traversing through a graph, and there are various ways, of course, to traverse through a graph. There's breadth first and depth first. We're going to cover both of those. With breadth first, you start at a starting vertex, and then you visit all the vertices that are distance 1 from that vertex. Then you visit all the vertices that are distance 2 from that vertex, and so on, without revisiting a vertex. So in this case, if we start out at A, first we would visit D or B, and it doesn't matter which order, it's still a breadth first search. And then after that, we would visit the nodes that are distance 2 away from A, and that would be E and F, doesn't matter the order. And then after that, we would visit the nodes that are 3 away, and that would be C. And then we're done because we visited all the nodes. So that's a breadth first search. Remember that. These are different. Answer these questions to make sure you understand the concept of a distance. This is a social networking connection scenario. And again, this is a distance. Taj's friends are represented by other people that are distance 1 away from him or her, and so on. So you can answer these questions. Find the closest item in a peer-to-peer network. You may, music sharing or movie sharing or whatever, that kind of application. Here, this is the algorithm. This is the for a breadth first search, and make sure you study this and understand how it works, because to do the challenge activities, you have to understand this algorithm. Okay, the way this algorithm works is it starts out with a start vertex, and it has 2 data structures. It's got a frontier queue right here, represented here. And then there's a set, which is called the discovered set. And we start out by queuing up the start vertex and adding the start vertex to the discovered set. And then we loop through. Each iteration processes 1 node that's in the frontier queue. And in an iteration, we add to the frontier queue the nodes that are adjacent to the node that we're processing, assuming that they're not already in the discovered set. So they're queued into the frontier queue, and they're added to the discovered set as long as they're not already in the discovered set. So you can click through that and see how this works. It starts out with just A. Just A in the frontier queue and A in the discovered set. And then we go to while, and we're going to process A now. We're processing A, and then we mark it as visited. And then we loop through and we add all of the nodes that are adjacent to A, which is D, and add that to both frontier queue and discovered set, and B, add that to both frontier queue and discovered set. And then next we look at the next node, which was B. And so we processed, which was D. We processed D. There's no more nodes to add from D. And now we're processing B. And there are 2 nodes to add from B, both E and F. We'll see E added to the frontier queue and to the discovered set, and F added to the frontier queue and the discovered set. And then we're going to go back up, and we're going to process E. That's the current. And we are going to, when we process E, we're going to F. We added F. And next, F is in there. We're going to process F, and that adds C to the front queue and to the discovered set. And then we process C, and there's no other vertexes that haven't been visited, and so we're done. Frontier queue ends up being empty. Okay, so that's breadth first search. Make sure you understand how that works. Let's do the challenge activities. Okay, so first of all, given the graph below and the starting vertex B, okay, we're going to start here. And the first question is, what is D's distance from B? And that would be 1. D is 1 away from B. What is E's distance? E is 1 away from B. What is A's distance? A is also 1 away from B. What is B's distance? B is right at B, so that would be 0. And what is C's distance? Well, it's also just 1 away from B. My goodness, what a simple one. All right, looking good. Let's do the next one. Okay, which of the following are valid breadth first search traversals when C is the starting vertex? Okay, so we're starting at C. So C has got to be the first one. Well, that's got to be 2, 3, or 4. 2, 3, or 4. And after C can be either A or D or E, cannot be F. C, A, it's got to be A, D, and E is the next 3. Okay, C, A, oops, wait a minute. C, and then A, and then F, and then D, that's valid, and then E, and then B. B's got to be last because that's distance. Let's see, 1, 2, 1, 1, 2. B has got to be last. Okay, so it starts with C, and B's got to be last. Okay, so this is a candidate. This is a candidate. C, B, C, A, D, E, C, A, D, E. Oh, this would not, let's see, C, and then this would not work because it can't go C, B. It can't go from here to here. So that's definitely not it. How about this one, C, D? Oh, that's not a candidate either because it goes from C to D to F. That's, oh no, that's okay. C, D, F, A, E, B. That looks like that'll work. This one will work. Okay, let's verify this. C, A, F, D, E, B. Okay. And this one does not work because it's C, B. That's not gonna work. So this one works as C, D, F, A, E, B. So that works. And this starts with F. Okay. So is that right? Very good. Whew, let's do the next one. Okay, I'm going to bring up a whiteboard here for this one. And where's my whiteboard? It's right over here. Let me get a new whiteboard. And let me try to put that over here. Let's see if this works. There we go. Okay, this is nice whiteboard here. Let me make it smaller because I want to use. Let's see, can I do this? And I don't need this. All right, so let me use a black pen here. Does this work? Yes, it does. Okay, so we are doing this challenge activity here, And what we need to do is okay, we're going to start out at A. A is the starting vertex. And which vertices are in frontier Q before the iteration of the first loop? If we remember the algorithm, shoots, I should have the algorithm up here too. Let me make this a little smaller, and let me go and pop open another instance of the book. And we are in graphs, and we are in breadth first search. And I want to have the algorithm here. The C algorithm. Tell you what, I'm going to do something different. Let me just. Okay, here's the algorithm. Okay, so let's go back to, I don't need this up anymore. Let's go back to here. What are the vertices in the frontier Q? So I'm going to make a table here, and I'm going to say frontier, frontier Q, and I'm going to say discover set, and I'm going to say after the 0th iteration, okay, so after the 0th iteration, the frontier Q is, we have up here, it is, it just contains the start vertex, and the start vertex is A. So front FQ is going to have an A in it, and the discover set is going to have an A in it. Okay. And now after the first iteration, we are going to be processing A. So A, so the first iteration is going to put it's going to take A out of the frontier Q, and it's going to add the nodes that are adjacent to A. So the nodes that are adjacent to A would be C and D. So the frontier Q is going to have a C and a D in it, and the discovered set is going to have the A in it, of course, and then it's also going to have the C and the D in it. So that's what the after the first iteration. After the second iteration, we are going to process the C in the second iteration. So this is going to go down to D to start with. It's going to go down to D. And the nodes that are near C, that are adjacent to C, that aren't already in the discovered set, will be added. And that would be E and F. So so E and F are going to be added. And they're also going to be added down here. So it's A, C, D, E, and F. That's after the second iteration. And after the third iteration, we're going to be processing D. So we're going to start out by removing D. And then all the nodes adjacent to D, and there are no nodes adjacent to D that are not in the discovered set. A is in the discovered set already. A is in the discovered set. C is in the discovered set, and E is in the discovered set. So there's no new nodes being added to the discovered set as a result of processing D. So it's still going to be A, C, D, E, F. Okay, so the question is, what are the vertices in the frontier Q before the first iteration? Well, that would be frontier Q has got to be A. Okay, And then which vertices are in the discovered set after the first iteration of the while loop? Okay, this is the discovered set here. After the first iteration of the while loop is this. After the first iteration of the while loop is that. So ACE. A, comma, C, comma, E, D, I mean, ACD. And then the third one is which vertices are in the frontier queue after the third iteration. The frontier queue after the third iteration of the is this. In the frontier, so that would be EF, I think. EF. And what vertices are on the discovered set after the third iteration of the while loop? Well, that would be these down here, which is A, C, D, E, and F. Let's see if this is right. Very good. We got it. Okay, one more. How many valid breadth first search traversals are possible when E is the starting vertex? Okay, so E right here is the starting vertex. And we're going to do breadth first search. Can I do something like... I think I can. It just makes a line, doesn't it? Do I undo something or? Oh, anyway, let me make a new whiteboard. I don't want. All right, so I'm gonna write down the paths from E. Okay, starting with E. What are the traversals? Well, there's the first, the distance 0. I'm gonna put distance here. Let me just do that. Distance 0 is E. Distance 1 from E is B, and D. Distance 2 from E is C and A. It's A and C and C. Okay, so so a valid breadth first search is first start out with E, and then it can be either BD or DB. So it can be either BD or E. I'm sorry, D. BD or DB. And then from there, it's either AC or CA. And same with this, either AC or CA. So the this up like that. This. So we are looking at, it's either E, B, D, A, C, or E, B, D, C, A, or E, D, B, A, C, or E, D, B, C, A. That's it. And that covers all of them. There's only 4 of them there. Okay, so the answer should be 4. And I'm going to see if that's right. And lo and behold, it is. All right. So I hope that helped with this challenge activity. Thanks for watching.